Hey, welcome to the ICE mission of the Avativut program. With Avativut, you participate in a real environmental monitoring. With the ICE mission, you will see how ice forms and transforms in your community. Moreover, you will help scientists to better understand changes and variability in the Arctic ice cover. That is useful work. How will we do that? Simply by using basic scientific techniques to collect data, such as interviewing, observing, describing, sampling, measuring, and analyzing. And today we'll explore the technique of observation.
In this activity, you must monitor the ice at the experimental site and observe when it forms and when it disappears. Maybe not, but there are signs.
For the ice to form, the water has to freeze. And of course, for the water to freeze, its temperature has to drop below the freezing point. But for the temperature of the water to drop below the freezing point, the temperature of the air itself needs to drop below freezing. So you'll check the thermometer on a regular basis throughout the fall season. When the temperature of the air stays below freezing day and night, it can take some time for a large body of water to cool down and start to freeze. For example, in Nunavik, it has been observed that from the time when the temperature of the air stays below zero, it takes 2 to 6 weeks before you can see the first ice forming.
So when you observe that the temperature is steadily dropping below the freezing point, you can expect the ice to be coming soon. So be alert and start watching the water near your community. Then run to the observation point.
When you get to the observation point, you'll see this strange box. This is an ice viewer. You use this to make sure that you're always looking at the same spot. It delimits the field of view. The field of view is the area you see when you look straight ahead, without moving. The ice viewer will limit your field of view. You'll only see what it lets you see. It's very easy to use. Simply put your chin on the shelf and look through the ice viewer. It is pointed at the sea or the river. And since it doesn't move, regardless of who does the observation, the field of view will always be the same. And when you look throughout the ice viewer, you should see if there is ice or not at the experimental site. You can then simply record in your notebook the date and time, and whether you see only water, water and ice, or only ice. A word of caution. It's very important to only record what you see in the ice viewer. If there's ice a little way off, but you don't see it throughout the ice viewer, then you must record that there is no ice.
Since conditions can change pretty quickly, it's best to do it every day. It would be very good for your health, but it doesn't have to be you every day. Thanks to the ice viewer, any student can do it. So you can all take turns.
For an
observation to be scientifically valid, it must be carried out in the same place and in the same way. Therefore, we're going to look through the ice viewer.
What matters for the scientist is to know the exact date when the ice cover appears for the first time, and the exact date when the ice cover is completed for good. Therefore, to know the exact date, you must go observe as often as possible. But if the freeze-up period is very long, you can go less often at the beginning and more often at the end. But remember, even if the ice cover is complete, it is important to continue observation for some time yet, because sometimes the ice cover forms and then, with the wind and tides, it disappears again. In some communities, freeze-up happens quite rapidly. In Umuyak, for example, it takes about 3 weeks in December. But in Kuujjuaq, the river may take up to 3 months to freeze completely in front of the village. Observation can stop when the ice viewer shows that the ice cover is complete and stays put for several days.
Siku ni maonepa. Teemo.
Not quite. You'll have to start your observations over again in the spring. At least in the spring, the weather's starting to warm up. You still need to keep an eye on the thermometer and the surface of the ice.
For the ice to melt, the snow on top of it first needs to melt. And for this snow to melt, 2 things are necessary: stronger solar rays or warmer weather. When the sun is higher in the sky and the day is longer, the snow can start to melt, even if the temperature is below freezing. This is the effect of the solar radiation. Obviously, it goes faster when the air temperature rises above freezing. When there's no more snow on the ice, then the ice can start to melt. At this point, watch the surface of the ice. It will change color. It may turn gray or even blue, and melt pounds will appear. Since the ice cover is still thick, the water can't run off. This creates little lakes or puddles that are called melt pounds. These melt pounds often freeze up again during the night.
When spots of open water begin to appear, you need to go back to the observation point every day because things can start to happen very quickly.
As you go to the ice viewer, you'll write in your notebook if you see only ice, ice and water, or water only. When you see only water, this is the final disappearance of the ice cover. Monitor the site for a few more days. If the ice doesn't come back, your work as an observer is finished. But if the ice comes back, pushed either by the winds or the tides, carry on with the observations until the ice has completely disappeared. Now that you have recorded all your observations in your notebook, the next step will be very important. You must fill out the table provided in the student's booklet. You will note the date when the ice first appeared and the date the ice cover completed for good. Then in the spring, you will also note the date when water first appeared and the first date when all the ice has disappeared. Then you'll record your observations on the Avativut website.
You can then compare your observations with those of the other villages or with previous observations from other years.
Oh, I'm certain too. It is hard but very important work. With your observations, scientists will be able to know the exact freeze-up and break-up dates, as well as the ice cover duration in your community. And with that, we'll certainly know more about warming of the Arctic. At Sunai,